Claude 3.5 Sonnet just committed suicide.
Yeah.
Hello everyone, my name is Arshia,
And I'm Yasha.
and welcome to the 8th week of AI over coffee.
Yeah.
This week we have a weird episode. We're going to show you a chess match between two different AI models in FlowHunt.
Brilliant chess match.
Brilliant chess match. It was one of the most insane chess matches I've ever seen in my life.
Yeah.
Like, Magnus Carlsen has nothing on these bots.
Exactly.
Like, it's insane, right? Yeah.
This was actually inspired by GothamChess.
Yeah.
And yeah, so he started this full episode of Chessbot Championship. And we thought, and the moment I saw it, I was like, he's doing like a really good job. We should also do the same, but we need to kind of use AI agents because for sure he's not using AI agents. So shout out to GothamChess, I guess.
So yeah, this is not just like purely two LLM models just going at each other. It's AI agents as those LLM models.
Yeah. But first, let's do an introduction.
Okay, so we have a flow here for our white team as Claude.
Yep.
We're using the latest model of Claude, 3.5 Sonnet.
Mm-hmm.
And on the opposing team, it's the GPT-4o.
Yeah. So
Right.
basically, the task is we want two chessbots to play a game, to play a chess game together, and we want to see like how does it work with AI agents. So do you want to like explain what you did in here? So the flow, how does it work?
Sure thing. So basically, the first thing that you can see is the prompt and the generator. That prompt and generator makes sure that it knows every single piece where they are
Yeah.
on the chessboard. So every single time we make a move, it's able to document where all the chess pieces are on the board, and we will see that it's doing an amazing job at doing that. And
Yeah, because the problem we saw in all the chess games that we did with like single LLMs or plain LLMs was that they had like after a while, like after I don't know, like let's say like 10 or 20 moves, they had no idea where the pieces are.
yeah, even though it was documenting it live every single time, and every single time it was gonna make a decision, it knew exactly where all the chess pieces should have been.
Yeah.
But just over time, even though we gave it 5,000 tokens for chat history, it still forgot.
Yeah. So and also LLMs have like limited context. So that's why we wanted to go with this path that okay, like in each conversation that you're gonna have or in each message that you're gonna have with the AI agent, we show a map or we show the latest status of what are the pieces of the opposing team and also your team in the prompt.
Yeah, so basically we're going to show you the limitations of chat history and AI because even though they're very smart and very fast, they're just like us, right?
Yeah.
So it's like when you have so many messages, so many long messages and previous messages, it's like, it's too much work. I'm just not going to read it.
True.
So yeah. And then after that, it's an AI agent, which we gave it the prompt that it's going to, based on the input, which is the move that the opposing team has made, it's going to make a counter move.
Yeah.
So yeah, I think we can move on to the video and see what happens.
So
we even gave it Google search and URL retriever so that it can like search on Google what the best counter move to a certain strategy is.
Yeah. But what we observed was that Claude searched, so the white team searched, but the black team didn't.
And what we also observed was that GPT-4o was so much better at documenting all the chess pieces.
Oh yeah.
Rather than Claude. Claude just didn't bother to do that.
Yeah, true. So we're gonna see. But I'm so my chess rating is around 800, maybe a little bit more because I haven't played much.
Yeah.
Arsha is how much?
640, 650.
Yeah, 640.
So we're not professionals
No, we're not
whatsoever.
professionals. But we know the openings. We know
Yeah,
some
yeah.
openings. So we're gonna do our best to analyze this.
Yeah.
Maybe. Okay, let's go. So the game starts with e4. This is Claude. So the white team is Claude. The black team is GPT-4.
Yeah.
Oh. So yeah, e4, c5.
Yeah, so the black team was going for the Sicilian defense.
Yeah.
Start.
Black was going for Sicilian defense. This is and also white's opening is like a kind of
It's like the
Roy
most
Lopez,
common,
or
yeah.
it's the most common. So usually what we observed was that the bots did a really good job in the opening, so they knew
Yeah.
their opening theories.
Exactly.
All right, let's go.
Still continuing with the Sicilian defense. White tries to take middle control, which was successful to some extent.
And then knight to f6. These are like simple openings. I think it's
they're not playing aggressively whatsoever.
Yeah,
they're
exactly.
They're both playing very defensive.
There's no gambits involved.
Yeah, very defensive, castling.
Oh, so
both sides castled.
Oh, also here, actually, Claude mentioned castling.
Yeah.
But then it was like, let's do a king side castling. And
even though it was a queen side castle.
It's a queen side castling. So
he very confidently said, "Oh, I will do a king side castle to defend my queen, to defend my king." And we were like, "That there's a bishop in the middle. That's not possible." So we were like, "Okay, then I guess he means the queen side castle." Exactly. So we just did a queen side castle.
And in here, wait. I think this comes here. Okay, this is normal. The castling is normal, and the first move here. So yeah, I think in here, White should continue developing their bishop, but they're like, it ends up in this situation. Black takes advantage by just taking the pawn. So I like, in my opinion, it's like a really odd move to just make your pawn go forward. And okay, so Claude knows that, okay, the knight is in danger, so it goes back, retreats. And now in this situation, both queens are doing a, how do you say it? Like, they're just seeing each other.
Yeah. You would expect a queen trade at this point, but no.
These are okay moves. It's not, and in here actually Claude did a really good job, because it found out, okay, when the pawn goes to b5, then this square, like the c5 square, is always for the take.
Yeah.
So I think Claude did a really good job in just expanding that. But I think now it's the time that the game goes. Yeah. So suddenly the queen turned into
a knight. Yeah. So it was White to move, and the queen went from what is it, d2 to b3. Yeah. So that's a very illegal move. But hey, and this is where you see them forgetting where the chess pieces are.
Yeah.
And I'm not meaning some of them. I mean most of them. It just completely forgot about the whole game and started to develop a brand new game. So let's see what else happens here.
Then he goes forward.
And then we're here, as you can see in the video, there's no moves being made, because we were like, wait, what happened? Why did the queen just make a knight's move? We were just confused. It was like, okay, I guess we'll just keep going.
And now the knight takes b5, which is a complete blunder of your knight.
Yep.
Right? I thought it was a sacrifice, but there's no sacrifice. There's no compensation whatsoever. And then this goes forward. Yeah, then Claude tries to sacrifice his bishop for nothing.
For no reason at all. Just give a free bishop.
Okay, the queen takes.
So as you can see so far, the GPT-4o is doing a better job, because it knows where all its pieces are at the moment.
Yeah.
Therefore, since it's documenting all the pieces, it's able to take advantage of the blunders that Claude did.
Yeah, and I think in this situation, like, taking a2 is like basically
a no-brainer.
Yeah.
I mean,
yeah, basically penetrate to the White's position. Okay. So in here, White noticed that c2, basically a2 is there, but also it's giving its own knight. So it should, like, GPT-4o should take the knight, but I think it doesn't. Oh yeah, so the first blunder, the first awkward move happens for GPT-4o.
Yeah, GPT-4 just jumps over the night.
Yeah.
As I told Yasha, these guys are on a different level.
Yeah,
so
right.
they're playing quantum chess.
Quantum
this
chess.
isn't normal chess anymore. It's beyond our scope of.
And now Queen ate its own pawn
Yep.
at C2.
So yeah, now Claude is like, okay, I have a very big disadvantage. GPT-4 is moving in, and Claude just doesn't know what to do, so it's just killing itself.
Yeah.
Wait,
and
what happened there?
Oh yeah. The white bishop teleported to C2. It just took the knight.
Okay. So it's a jumping rook.
Yeah.
Yeah. Jumps over two like knights and then just kills the pawn.
Exactly. But let's wait until the twist. White does really something awkward. So in here, the rook was threatened.
Mhm.
And Claude found out, okay, I need to move my rook, and guess which square did it?
It has so many different availabilities, but
Yeah.
it decided to kill itself.
It killed its
So-
own king.
Claude 3.5 Sonnet just committed suicide.
Yeah.
He was like, yeah, this is too much. I can't take this anymore. I don't know what to do anymore. I'm just gonna kill my king.
Yeah.
So
yeah, that's-
and just like that, the game was over.
Exactly.
There's actually a special game mode from chess where you have to kill the king and not checkmate them.
Oh really? Okay.
Yeah, I think that's what Claude 3.5 was playing, but against itself. So Claude committed two murders on two of its own pieces.
Yeah. The pawn and
But, and we saw two flaws on the GPT documentation.
yeah.
So it made two illegal moves, but Claude was just going crazy. And we printed all the thought process behind all their moves, and it was making sense for a very long time until
Yeah.
it just didn't.
Until I think until the opening, all models do a really good job, and then when it goes to the middle game, and they just blunder out everything.
Yeah. So yeah, that was a very nice game and a very nice match against Claude 3.5 and GPT-4. So GPT-4 clearly wins not by checkmate, but by suicide.
But these are language models, so they're trained to be as general as possible. For
Yeah.
sure, we're gonna see better versions of them in the future.
Okay, so that was the chess part of our video.
Yep.
And now we're going to talk about some of the things that happened in CES 2025, which is very interesting and very AI heavy.
Exactly.
Previous years, there was mostly nothing mentioned of AI, maybe a little bit here and there, but it was mostly like hardware accelerations in the hardware field and how they were able to improve performances in different ways. And this year, it was all about AI.
Yeah.
Everything was about AI.
Cool.
So yeah, here we have a little bit of keynote from Jensen Huang, the CEO of Nvidia.
Yeah.
So you can go ahead and.
Okay, so basically, he started his keynote with all the paradigms that AI is going through. We passed the transformer models, all AI large language models. Now this year is going to be mostly agentic AI, so all AI agents, what they can do, how they can help the industry. And what the paradigm that we're shifting to is physical AI. So that means all robotics, AI integrated into robots.
Yeah, for sure. The next industry we're gonna see a boom in is gonna be the robotics industry.
Exactly.
For sure.
Yeah. So I guess he is the better person to see the keynote. So we're gonna see a section of the keynote and then we're gonna
all of these types of understanding, is intuitive understanding that we know that most models today have a very hard time with. And so we would like to create we need a world foundation model. Today we're announcing a very big thing. We're announcing NVIDIA Cosmos, a world foundation model that was created to understand the physical world. And the only way for you to really understand this is to see it. Let's play it. The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label. Nvidia Cosmos is a world foundation model development platform to advance physical AI. It includes auto-regressive world foundation models, diffusion-based world foundation models, advanced tokenizers, and an Nvidia CUDA, an AI-accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data. Whether diverse objects or environments, conditions like weather or time of day, or edge case scenarios.
Yeah, so you see, like, they created like multiple products together. Cosmos is one of them, which is, it gives you the whole environment for developers to that have diffusion models, transformer models in one product that you can use to train all these models. Mostly for inventory and all these big scale companies that they want to automate their inventory with AI. And the problem that they are facing is mostly they don't have training data, and there are really limited number of companies that have training data. For example, Tesla has the biggest training data for its own cars, for like self-driving cars. But for example, not other companies like Mercedes-Benz have this, because they didn't have it at the start. They haven't installed the sensors from the start, and so this is a pipeline to create synthesized data. That means like data that is first created by humans, and then there will be an AI trained on that to create different variations of the same place. For example, you would just give your 3D model of your inventory, and then it would come up with different scenarios that the AI should be trained on, so that it can be really trained on edge cases, all specific cases. And then you would train this model with reinforcement learning or similar. You have also video tokenizer, so with video. And then it's like a virtual environment for your AI to be trained on. And when you think it's now trained on really good data, then you would just deploy it in the real world scenario to.
So we can finally see AI learning what real world physics should look like.
We'll still a lot left until then, but I think current models are not able to do that. Still, there are, for example, Jan LeCun is the father of AI. He's actually doing some research on this. So we need a lot more research in this area with better models. But this is like a good way, at least for now, to train the AI models that we already have. And when the research also catches up with really understanding the world model, then it can be integrated to this, and it can be really, really cool.
Yeah, very nice. Okay, so something else that happened over at CES 2025 was Nvidia Digits.
Yep.
So tell us what it is.
That's a new project. So the whole point is, right now the startups are really going to be focused on AI. So that's why you need a PC that is really AI oriented, and that's the whole point of Project Digits. So Nvidia just built a kind of a PC, if you will, that has 4 terabyte of SSD, and it's all AI oriented. So it has 1 petaflop, of AI compute, and you can run like 200 billion parameter AI model on it.
Yeah. So and it has 128 gigabytes of unified memory.
Yeah.
And it's a module-based system hardware where you can pair up two of these devices together, and they will
Exactly.
work spontaneously.
Yeah. So you
Together.
can you can use two of them to run Llama.
Yeah. So it's like old SLI GPUs where you just
exactly.
crank them together and they work. Speaking of AI hardware, they just announced their brand new graphics cards. And the base model 5070 is supposedly going to have the same performance, at least in gaming and AI, as the previous flagship, which was the 4090, which has never happened before. Usually the way they go is like the flagship of a certain generation stays the strongest than the like base models for like 2-3 generations. But this time this didn't happen, and it was only thanks to their brand new DLSS 4.
Yeah.
So for example, in gaming and in computing, it renders a single frame or a single computational task on your computer and 4 other frames with AI.
Yeah.
So it predicts what's going to happen on your screen, and it just renders them before
Yeah,
it
and they
even
actually
happens.
showed it in the keynote. So
Yeah.
like 10% of the whole frames are just generated traditionally by what the games were programmed to do, and then the rest like 90% of it was
AI.
generated by AI.
Yeah.
So that's really amazing.
Yeah, this all obviously has some flaws at the moment, which is shadowing and a little bit of input delay. But I
Yeah.
think in the next few generations, we're going to get over those, and we're going to see a very big revolution in the gaming and rendering scene soon. Because like nowadays, they're doing movies with Unreal Engine 5, which is like, okay.
Yeah.
So they're using game engines to make movie CGI. It's that good at the moment. So it's pretty interesting. And another AI news that was really nice in CES was Project Ava from Razer. Razer only makes gaming peripherals. So like keyboards, mouse, mice, headsets and whatnot. And this year they came out with an AI model of their own,
Yeah.
which is basically an AI gaming assistant that tells you what to do, when to do it, and what to do. So basically, no more going on the internet to see how you can do this Elden Ring quest. You just ask your personal Ava. It's like, hey, Ava, I don't know how to get this weapon. How do I get it in Elden Ring? And it gives you live directions on what to do and when to do it, which kind of sucks out a little bit of the mystery of the game. But
Well,
I guess for the casual people
You're
that
gonna
want
be more
this,
productive. That's
yeah,
what
that's true. That's true. It's gonna be an advantage for sure. But yeah, there was a lot of AI heavy things at CES 2025, and I'm gonna link it down in the description. I'm gonna give a summary video from another YouTube channel.
Yeah.
All the cool stuff that happened in CES 2025, and yeah, you should go check it out. It was really cool this year. It was really nice.
Yeah.
It was very revolutionary, and
This year is gonna be crazy.
oh yeah.
We're gonna see.
And I can't wait for next year. If this year's like this, next year's gonna be nuts. So that's all for today, I think, yeah?
Thanks for GothamChess for inspiring
Yeah.
us.
Thanks for GothamChess. All right, thank you so much
All
for
right,
watching,
thanks.
and see you guys next week.
Bye.
Ciao.